So we have seen few example where we utilize two pointers technique and solve the problems efficiently, like finding a string, whether it's a palindrome or not, reversing a string with uh, time complexity O(n) and keeping the space complexity to O(1). Now, I would like to give you another example where we are going to merge the two sorted array and using the two pointers. In fact, we're gonna improvise this two pointer technique and going to use three pointers instead of two pointers. So let's see this. I'm going to show you this lead code, problem number 88. Okay, in this problem, the ask is you are given two integers, number 1 and number 2, sorted in non-decreasing order, and two integers m and n, representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single sorted in non-decreasing order. The final sorted array should not be written by the function, but instead be sorted inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denotes the element that should be merged, and the last n elements are set to be 0 and should be ignored. nums2 has a length of n. Okay, so we have understand this with the example. We have given two sorted array in non-decreasing order, and also we have given the two numbers which are representing how many elements in the given array. Okay, and we have to merge them together, and we need to write a function which should not return anything. Instead of that, we just accommodate the second nums2 array into the first one, nums1. Okay, so you can see this nums1 here. The input nums1 equal to 1, 2, 3 and 0, 0, 0. M equal to 3, nums2 equal to 2, 5, 6 and n equal to 3. The m in the first, m showing the number of elements into the first array, n is the number of elements into the second array, right? And also in the problem statement, we have been told that the total length of nums1 array is equal to m plus n. Okay, this is very important and useful information to consider. We don't have to return a new array. We have to accommodate the nums2 into the first one, and it should be sorted non-decreasing order. So when we pass these two inputs to our function, it should return as 1, 2, 2, 3, 5, 6. Okay. We are talking about the two pointers technique, right? Now think about these problems, how you can utilize those two pointers technique to solve it. And uh, instead of the two pointers, I'm going to uh, improvise it with the three pointers. So let's see this one in the picture, like how we can uh, approach to the solution. Okay, so here we are, the pictorial representation of the two array. This is my nums1, this is my nums2. And as you can see, the length of the first array is 1, 2, 3, 4, 5, 6, and 3, right? as per the question, this is representing as m, which is 3. This is representing as m, which is also 3. And the total length of nums1 is m plus n. Okay, now what we have to do is we have to insert all the element in nums2 into the nums1, and we also need to make sure that they are still in non-decreasing order, meaning sorted, right? So how we gonna approach, right? So as we are talking about the two pointers, we are exploring the two pointers technique. We are going to use the two pointer technique to solve this. And so one pointers, I'm gonna say pointer 2 would be this guy for nums2, and pointer 1 for the number nums1 array. Now it's initialization of these two pointers are important. How we gonna initialize and how we can proceed. Okay, so you can think it like these are assorted array, non-decreasing order, right? 1 2 3 0 0 0. So any numbers, if it is greater than 3, should be placed after 3, and if it is less than 3, should be placed before 3. So that means, like for example, if we look at the first element of the nums2, which is 2, so we have to place this somewhere between 2 and 3, right? Not 2 and 3, right? So we have to move this 3 to the different place here, to the different index, and place this 2 here. Then it will be becomes 1 2 2 3, right? Now with this two pointer technique, what we can do is we can initialize our pointers to the end of the array, like this pointer 2 and also the pointer 2, pointer 1. And what we can do is we can compare these two number, right? And based on the outcome, if the value in nums1 is greater than value of nums2, then we have to place them where? We have to place them at its right position. So let's say we initialize the two pointers, one pointer at the end of the elements in the nums1, and the another one is end of the um, array of nums2, right? But what the third pointer, what we can do is we're gonna utilize and we can initialize it here. That is my pointer 3, and we know that, right? All the elements. So the length of the nums1 is given that it is going to be m plus n. So if this whoever is greater in this two should be placed here, it will be replaced here. So let's say we are comparing the value at pointer 1 and pointer 2, which is 3 and 6, and we see 6 is greater. So we're gonna place this guy here, right? We're gonna move our pointer 2 to the next element, which is a 5. Now this one, right? Now we are comparing this 5 with 3 again, and since 5 is bigger, we're gonna place it again to this point, this position. We're also moving this along here. So it's 5 here now, right? Now we'll have our pointer 2 moves back to the position here, and my pointer 1 is still at 3. So now I'm comparing 2 with 3. Yeah. Now I'm comparing 2 with 3. Obviously 3 is greater here. So I'm gonna move this pointer to this place. This becomes empty. And since I ran out of this one, right? This is only two left in this one. So this is gonna go and we're gonna place it here. So by doing this, we got 2, 2, 3, 5, and 6 as the outcome, right? So as two pointer techniques, what we did, we initialize our pointers to the end of the array and the number of len, like the first pointer 1 is equal to m, pointer 2 is equal to n, and the pointer 3, which is m plus n minus 1, right? This is going to be m plus n minus 1. And this is also m minus 1 and n minus 1. And we are moving these three pointers in harmony to get the desired result. So let's see how we're gonna convert this into the algorithm. So here's the fun begins. As we discussed, we are going to need the two pointers, right? So I'm gonna initialize the two pointers. Pointer 1, which is going to be m minus 1. Pointer 2 is going to be n minus 1. And as we say, like we are going to improvise it with the three pointers. So we are going to call it merge index, and we're gonna say that is going to be m plus n minus 1, right? Then we need to loop through it, the first one. So what we're gonna do is we're gonna start from the end of the nums1, right? And we're gonna make sure that p is greater than or equal to 0 until we reach the first one. We'll keep doing this. Okay. The first condition I would like to add, if my pointer 2 is less than 0, okay, I can simply break. Like if there is nothing in the pointer 2, we can just break out of it. We don't have to do anything. And whatever in the elements in the first array is already good. Now, secondly, we have to also making sure that the pointer 1 is greater than or equal to 0 and nums1 at pointer 1 is greater than nums2 pointer 2. If it is greater, we are going to place that at pointer's position, that is the third pointer, and so that's gonna be nums1 pointer 1 and also decrement it. So that's my decrement here. Similarly, if nums2 value is greater than nums1, then we gonna replace the nums1 with nums2. We're gonna place the nums2 value at the end of the array, right? That's gonna be continue until we finish the loop, right? So yeah, that's it. See, that's two pointers we initialized at nums1, nums2, right? The pointer 1 is pointing to the elements in the given number 1 array, and the pointers 2 is pointing to the last element in the nums2 array. It is given that nums2 total length is m plus n. So the last index of the nums1, if we're gonna place all the elements, should be m plus n minus 1, and we are looping through the we are looping into that, and just making sure, just comparing the pointers, the value at the pointer 1 and in the nums 1 and the value of pointer 2 at nums 2, and just putting them, backfilling them into the first array from the back. So let's run this, and it should be okay. We got some error, so compilation error, pointer 2 illegal start. Oh yeah, I just forgot the zero, sorry about that. Let's run it again. Pointer to nums1. That was some spelling. So that should be good. Yeah, awesome. So as you can see, the results are as expected for all three cases. So that's it about the two pointer technique, right? You can see the we are doing the in place everything, right? So we are not using any extra space. So OSPs, the space complexity for this is just like three pointers, which is O1, and it is very efficient, right? Okay, thank you for watching, and